third list tells us what they add to. So we're looking for whole numbers in list 1, list 2, and our b value in list 3, because we want those two numbers to add to that, okay? So we're trying to find -2. Oh, right there.
Yep.
So this actually simple, or you know your factors to that already. Just using this in that, this is really helpful, especially when you're getting into giant ones. I won't make you guys do it. Say I wanted you to do 4x squared plus, minus 165 plus 314. Trying to find factors for that. It's not pretty.
Is that 165?
Yeah, sorry. I kind of goofed. But trying to find factors for that is not fun. Okay. Well, we can plug that right in. I'll actually plug it in. Sweet. So we need to know what 4x times 314 is. I'm just going to put it in parentheses because I know it's 4 times 314 divided by x. 4 times. And you can evaluate it and then put it in. I'm just, so I don't have to deal with how slow this thing is. I'm just going to try to do this. So now, when we go to our table, we're looking for whole numbers. And they need to add to -165. So, as we're going through, that number's getting smaller. So, we should probably check, go to x. We should probably check out the negative numbers. Okay, so now our third list is negative, because we're looking for a negative number. We're looking for 165 in our third list, and whole numbers in our first and second. And holy crap, there it is. Apparently -8 and -157 are the factors for that. So, now keep in mind, this is just a trick that she made up on, more or less, for that occasion. I've got one that I came up with. Now,
This is cool.
this one doesn't work for imaginary numbers, at least as far as I haven't goofed off with the imaginary number output. Okay.
If you take the imaginary number out first, it doesn't matter.
If you're working with imaginary numbers, you should want to know how to factor them out. Okay. So, say we have the square root of 81. We all know that's 9. Okay? Say we have the square root of 72. What does that factor out? Simplify it.
6 root 2.
6 root 2?
Yes.
Yeah.
Yes, Brian.
Okay, so. Oh, we forgot that.
You got what? No, we're not putting the square root on this intentionally.
So, I thought, what about this? Okay. Essentially, when we look through our table, it's going to plug in numbers for x and square it. And then our second list, it's going to tell us what that's first list, well, second, okay, second list, it's going to tell us what x squared divided into 72 becomes. What if that's a whole number that divides evenly into 72? So, if we go to our table, we look for 6. 6 squared goes into that evenly.
And leaves us with?
So what that means is, I'm looking through this. This is what's going to get factored on the outside, and this is what's left in the root. And now it's really, really, really nice for this, especially for professors. You can check any sort of factor. So if it needs to be factored again, if a student doesn't factor all the way, you can still see we know this is still 4 root 8.
3.
I'm looking at a weird angle, and it looks like 3 is to 18. 3 root 8. Sorry, I'm looking off the list. So if a student doesn't go far enough, you can see every option available. Now, you've got 5 questions. I want to ask you, what if I wanted you to do the cube root of 540? How would I want to modify that equation?
Wouldn't you just change the 2 to a 3 on the x?
Because then it'll cube the x and divide it into it.
We'll make it 540 as well.
Oh, well, you also got to change.
True story.
Very true.
And then that same trick will work. Once you find whole numbers, the number in your first list is the number that goes down in front. The number in the second list is what stays in the group. And it can be any set of factors. Once you get in your list 2, once you get below 1, I wouldn't go much further. Because that means x is officially bigger, or x, whatever power is bigger. So this works for any power, or any root as far as I know. Feel free to try it out. There's countless tricks. I haven't come up with them all, but do you see how this is helpful towards maybe a 131 student that has crazy roots or something? Well, intermediate algebra or pre-calc, or someone that's, or maybe someone in real life that has to do some really big numbers. This helps them all the way through. Okay? So any questions on that? Okay, so I got one more thing, and I'm going to kind of fly through it. Okay? Okay, so last thing, I call it mass data, input, and storage. Okay? So we know that L1, or the lists, are just lists of numbers. Okay? So say I have that. So I showed you all that stuff. Say I wanted to do 3x squared plus 2x minus 5 2x squared plus 3x minus 3 and 3x squared plus 5x minus 5. Okay? So, and of course they're all wide. And say I wanted to plug in values for each one of these. Okay? What I can do is, how do I want to set up? Or say I wanted to solve for each one. Okay? What I can do is, I'm going to plug in the constants, because we all know the quadratic formula. Okay? Say I wanted to solve this where, or set it equals 0, solve using the quadratic formula. Negative b plus minus the root of b squared minus 4ac over root of a. Okay? So what if I assigned all my b values to a list? What if I assigned all my a and c values to a list? Maybe b was L2, a was L1, and c was L3. What that's going to look like is 1, 2, 3. 2, 3, 4, 5, 8. And then our third list. Darn me, negatives. -3. And -5. Okay.
Did you mean 3, 2, 3?
Yeah, not 1, 2, 3, 3, 2, 3.
Or 3, 2, 3 for your x's, for L1.
1, 3, 2, 3. What did I? Oh, okay.
It's easy as 1, 2, 3.
I'm much better with a calculator, I promise. Okay. So now we have all these assigned to a list. Well, remember how I showed you guys the fraction bar and how nice the fraction bar looks on the square root? Watch this. Numerator over denominator of.
You can tell they kind of thought that went into this. I mean, they thought people wouldn't mind if they didn't spend any time on it.
Square root of. Now I'm assuming L2 is b. squared minus 4 times L1 times L3 all over 2 times L1. So that's going to actually plug in a list. And now we're going to get a long answer for each answer. We just found out the x for all three of them. What if, say, you wanted to do 200 of them over some sort of real-life project? Then you're like, well, now I have to scroll through all the way through it to find each one. That storing trick that I showed you, we have L1 through L3, so I'm going to store it in L4. Voila. Now they're all stored. Each x answer is stored in your L4. And then if I want to just pull from again and swap that minus or that plus into a minus, make sure we save it to L5. Okay, at first.
That didn't freeze, you were just off the equation.
Anywho, you guys get what I'm saying, right? So, is there any questions on any of that stuff? I know we started off pretty basic to get all the rules and definitions down, but there's no limit to what you can do with this calculator. If you guys have any cool tricks that you'd like to share, George and I's email are right on the sheet. If you guys have any questions, you can always ask us. But there's no limit to what you can do with the calculator. Actually,
There's a whole lot more that we can add.
there's a whole lot.
My favorite thing is.
Can we all thank Brian and George for presenting today?
We got it.